I guess we'll get started a bit late, so we're going to have to make way through this quite quickly. But hey guys, I'm Phil. I'm a software engineer for cache converters. I was OCM with CFC last year, had some fun times, graduated, then went straight into work. And now I'm presenting a workshop on software architecture for you guys and how software communicates with each other. So the topics we'll cover today is just a bit about software architecture. The two main ones we'll cover is the model view controller and model view, the model architecture that we use. Talk about the differences of both, what's good about them, what's bad about them, and then we'll talk about how software communicates with each other, particularly with APIs, because we do web development and we talk about the REST API. So, software architecture. So the main idea behind software architecture is to provide a blueprint and the foundations of your a high-level overview of your software. And the main goal is to address the principle of separation of concerns. So the separation of concerns, the goal of it is to establish a system that's well organized where it's split into each section, where each section has a designated role, and it's just split out into things that do specific tasks together. Software architecture is important for the flexibility, scalability, and growth of the system. So if the separation of concerns is addressed correctly, each section will have its own fit, and that can grow by itself. The architecture of the software is critical to this success, because again, it's all to do with you managing it as the system grows. And by separating concerns into different role into each section, we can then use specific technologies for those sections that will benefit what we're creating. So, for example, by splitting it out, usually like the front end and the back end, we can use technologies that our developers probably be comfortable with, or that do the thing that we want them to do. And I got a little, if your software goes bad, I found some little gifts, and they're just poorly designed software, which is really banging your head against the keyboard. First one we'll talk about is the model view controller architecture. So in the model view controller, your sections are split into three, and those three sections are your model, your view, and your controller. The model deals with the business logic and grabbing data from your databases. This usually involves ORM, which is an object relational method. So you grab your data, turn it into usable data for your system, and then send it off somewhere. The view is your user interface, so that's your GUIs, and that they listen out for events and stuff that the user does on the front, and sends them away to get processed. And the controller is the mediator between the view and your model, so that it listens to any requests that come in from your view, deals with it, sends up a query to your model will then deal with that query, grab the data, do what it needs to do, send it back to the controller can then process that data, send it back to the view for it to be displayed and whatnot. Here's the representation. As you can see, it's a linear implementation of the model view controller. There is also a triangular implementation of MVC, and the only difference is in the way that each section talks to each other. So in the linear one, the controller is the mediator between the view and the model. In the triangular one, the model can update the view directly, the view can update the model directly, and so forth. But again, it's perfectly valid implementation. And just a thing to be aware that each framework will implement the MVC pattern slightly differently in terms of listening to the view, talk, and the communication between each of the three sections. So get to know your frameworks. The next architecture pattern we'll talk about is the model view model. Similar to the MVC in terms of those split into three sections that do something similar, but the main difference is this view model. So in the middle, So this view model is sort of like a controller in terms of it deals with the business logic and talks to the model. In the difference is that it is binded with the view. So I can't use my hands. So hello, come in. The view and the view model bind in a process called data binding. Each framework will implement this a bit differently. When the view and the view model bind it, anything that happens in the view model goes straight, you see straight in the view, and anything that happens in the view we heard or listened to in the view model. This can be done usually through commands or events. And you can see the flow is very similar again. So something will happen in the view, it will listen to the view model, picked up by the view model, which will then send a request to the model. It will do its things, send back some data that you requested, and because of its the binding, that data can automatically go visible straight onto the view. So MVC or MVVM, well, they really are dependent on the type of software you're making, the technology you want to use. We'll go around discuss both a little bit. So the main con of MVC is that it's got a clear separations in its concerns. So the view is separated from the controller and separated from the model, whereas in MVVM, the view and view model pretty much they are linked together, they're binded together. The biggest advantage of having this clear separation is that we can use different technologies, different frameworks for each section to optimize both development and performance of our system, like I said at the start. Another one is that it's easy to develop and maintain large complex systems because, again, of the separation. One of the biggest cons is the difficulty to implement with different programming languages and frameworks. Not all frameworks will implement MVC for you and have it built into them, so it makes it slightly difficult. And the other main difficulty is that it's hard to develop modern user interfaces because MVVM does a bit better because the view and the view model literally bind together. And the pros and cons of MVVM. So one of the pros is that it's very flexible for building GUI applications. Every view should have its own view model that it's binded to, which makes it really easy and powerful for building user interfaces, basically. The difficulty is that it can be more difficult to implement in MVC in some cases. You'll see the real benefits of using MVVM in much larger projects than compared to MVC. MVC is a bit more simple, a bit more straightforward, where MVVM's real advantage comes in bigger, more complex systems. And another pro and con of MVVM is its data binding. So why is it good? Well, because it automatically binds the view model to the view. So anything that happens in the view automatically updated into the anything that happens in the view model, that data is automatically synced to the view. Anything that happens in the view will automatically be heard by the view model, and it can deal with that. The con of this is that it can make debugging and troubleshooting applications a bit harder. Just in terms of every view has its own view model, we can find which one is the problem. Now that we know a little bit about how to design systems, we can talk about how each system talks to each other. As you can see, we'll be talking about APIs, but there's a few other means of communication between software. A few to look into. My particular favorites are sockets and buses. They're a good alternative. They're more for sockets for web stuff. Buses are probably used for bigger systems that talk to different services. So the API. The API stands for Application Programming Interface, and it's basically a mechanism that allows two different software to communicate with each other in a consistent way. So each API uses a set of defined protocols, or not commands, sorry, just definitions of protocols, which we will cover REST. The APIs work as the controller in model view controller systems. So the view will send a request to the API. API will then handle that request, do what it needs to do, send up another request to the model, and vice versa. And APIs can also be used in model view model structure, so we can talk from the view models to the models to go about data that way. REST is just one of the constraints we can use while building our APIs. So there's a whole lot of specific rules around REST. We won't go over them too much, but I've provided a link if you want to read more. We just don't have much time. The main thing we need to know is that it's just a constraint of how we can create our APIs, particularly for web services. There's a few naming conventions around REST. So each HTTP verb, as you can see on the side, corresponds to a CRUD operation. So if we want to post, that's when we usually going to create or update a row in our database. Reading is signified by the get verb. If we want to update, it's either put or patch. And then if we want to delete something from our database or model, it's pretty straightforward. Here's just a little example of how that works. So we have our endpoint users. If we want to read from that, we send a get request to that endpoint. If we want to update that endpoint, we send a post request. And we can be a bit more specific by attaching the user ID to get a specific user or update a specific user or delete a specific user. So why REST? Well, REST is really commonly used in APIs everywhere, both for web and console applications. And the reason for this, one of the big ones is scalability. So REST APIs are able to handle a large number of requests without affecting the performance. This is due to their stateless nature, which is one of the 6 constraints of REST. So any request that comes in, we don't really care what happened before it or after, we handle it as its own thing. Another big plus is the flexibility, so it's able to support a large number of different data types and content types. So if we're sending data, we usually send that in the form of JSON or XML, and that can be interpreted by any other system using ORM into whatever whatever classes or objects they use. Another content type that APIs or REST APIs can send back is full pages. So that's your HTML, CSS, JavaScript attached, and that leads into client-side and server-side rendering, but we don't have time for that today. Another one is the interoperability. Always have trouble saying that word, but basically it can be used by a lot of clients. Again, because everything's through JSON requests, it's very easy for many systems to just send requests to each other. It doesn't care how the other side's doing it. It's just sending JSON at the end of the day, which anything can do. And the last point is that it's very easy to use. So it follows a simple protocol, hopefully HTTPS, but still HTTP is fine. And all you need to do to hit an endpoint is to know its URL. So it's very easy to use. We'll do a little demo now. We're going to implement basic MVVM. We're going to be building a little to-do app using the MVVM architecture type. And to do this, we're going to be using Vue 3. So basically, let's start building this app. The entire thing will be available on GitHub so you can see the source code for yourself. But to start a Vue app, we run this npm create beat at latest, and that dot is just to specify that we want the current directory dash template, and we're using Vue. We run npm install to install our dependencies, and when we want to run it, we use npm run dev. So I've got a little example set up here with Vue. I was going to go through it one by one, but due to time constraints, I've just got to point it out. But we're going to go through it one by one. So the main things, it's just a simple Vue app. We just have a CSS is already implemented for us, and I just got this by asking ChatGPT to generate a CSS folder for a to-do app in causes colors. So if the colors aren't correct, blame OpenAI. So basically, what we'll start is we're going to start by defining our some variables. So we're going to have some to-dos. We're going to have an input where that will allow us to type that stuff, and then we can add some. We're just going to add some cute little things in here to make it look pretty. Run npm run dev. I can't set up, sorry. Can you guys see that one? It just needs to be any large from it. Is that okay? All good. If we go ahead and save that, we can see we now have just a few little headers that welcome to the Vue to-do list. We have some variables at the top. We haven't done anything with them yet, so let's go ahead and do that. First thing we want to do is create a form so we can submit or add some more stuff. And we'll give that a little header inside. If I update that, what's on the to-do list? We'll go ahead and make an import for that. This isn't really to a Vue tutorial, so I'm sorry if I'm speeding through a little bit. We're going to have an input of type text. It's just going to hold. This is an example. As you can see here, so here's where the data binding starts to take place. So Vue is MVVM by nature, and to perform this binding, we use this v-model. So this says binds the content from this box to our variable input content. And you can see if I zoom in a little more. Oh yeah. I just have the two remotes.
Is there something else?
I'm just going to turn the TVs off. Oh wait, I should probably point this way.
Yeah. Oh. What you do?
Hit the button underneath. This one's on the phone or no one does that. We all good now? Cool. So our input is binded. So view separates the view and view model. It's in one file, but the separation is that the view is stored in the template section. So this bit here, the template is the view. Then at the top here, your script is your view model. This is where the logic happens, and it's binded to the view. And the way we do this is to bind an input to our view model, we use this v model. And now whatever we type in this box will be stored in input content. Go ahead and save that. And now if we type something up, there you go. It's updating our input content on the view model, and we can display that directly to the view again. If we move on to the next bit. So it's all well and good to have just a text that shows right below where you typed it, but we want to store this somewhere. So on the form we have this at submit .prevent default, and we're going to, on submit, we're going to hit this add to do function. So let's go ahead and comment that out. So add to do will be called by the view on submit, and all it does is take the input content, trim it so we don't get just spaces, and then it's going to push the value into our to-dos variable here, or the array that just holds our to-dos, and the things it's going to hold is our content, which is what we just inputted, and our time, so we can sort them later. And that's all well and good, but if submit button is not there, that's probably why. Let's get our submit button showing. So now we have our submit button, and I'll just put the to-dos just below so we can see what's going on. So if I have one to do, it will be the customer again, and you can see it's popped it in, and just because we don't have any validation to it, we can just keep popping it. Cool, right? We've got working to do out. Well, if we refresh the page, that's all gone, because we don't store this data anywhere, and that's where we need our model to come in. So our model will come in the form of local storage. We don't have some fancy big ORM that talks to Firebase, sadly, but we've got local storage, which is just about the same. So this watch function will listen to any changes in to-dos. So any event that, I don't know what it's called in view, but when the properties change, we'll listen to that event, handle it as it needs to. This deep true just means that it will listen to any changes in the to-dos of values of inside the array, not just the array itself. It will listen to changes in any of the values. And all it's going to do, it's going to call this, it's going to hit this local storage endpoint, and using the local storage API to save our to-dos, save our item in a column called to-dos, and we're just going to make this array input into a JSON string. So if we go ahead and save that, test it out. Can't really see anything that's happened, but if we go into storage, local storage, you can see that there it is. We've got it saved. let's go ahead and display our to-dos that we have. So we have this section called to-do list. And all it's going to do is loop through the to-dos in descending order, which we'll go ahead and uncomment that out as well. And now it should display our to-dos in the order they were created. So if I type in another one, so I've got to say hello to Mef. Add that in. It is now the newest one, so it sits on the top. But again, when we refresh, that to-do list is gone. But if we see in local storage, it's still there. So the problem is that we're not grabbing this data. And that's where this onMounted call comes in. So onMounted listens to the event that is fired when the view is created, and it does a thing. So in this case, what it's going to do is it's going to update our view model property that to-dos and just add a value to it. What it's going to do is going to go to hit the local storage API, and it's going to tell us, hey, let's give us everything that's stored in the to-dos column. So it's sending up the model, which is in this case local storage going, yep, sending it back, and we're going to pass it into our to-dos property. And because of the binding, this is going to automatically show up in here with no problems. Go ahead and save that, reload this again, and as you can see, the mounted event is fired, onMounted is called, we've gone and asked our view model to hit the local storage, which is our model in this case. That's returned some data, and we've stored that data, and due to the data binding between the view model and the view, that data is automatically on updating our view here. And we can keep going, just adding more stuff, and it'll continue to do that for us. So the main takeaways is this binding between the view and the view model, the fact that view implements MVVM out of the box, and just the separations of it. So the template, again, is the view in this situation. The script above at the top is your view model, and we're storing stuff using local storage, which in this case acts as our model. So by hitting that API endpoint in local storage, we can store our data. We don't care how it does it. It's there for us to play with. Any questions? Cool. Thank you very much, guys.